Students, let's start with today's topic, electricity. So this is also a very simple chapter if you go through with the concepts. So here are few definitions and then laws are there, two important laws, that is Ohm's law and Joule's law of heating. Then numericals are there and two derivations are there, resistance in series and resistance in parallel. So only few topics are there which you can easily revise within half an hour. So let's start out with the topic. So the first topic of the chapter, what is electric current? So this is a definition. If net charge Q flows across any cross section of a conductor in time t, then the current I through the cross section is I is equal to Q upon T. So this is a definition. So what I is Q divided by T. That is Q is the charge and T is the time. SI unit of charge is coulomb, whereas the SI unit of time is second. Therefore, SI unit of electric current is coulomb per second, or we can use ampere on honor of the scientist Andre Marie Ampere, who discovered electric current. Now the next important question which can be asked is other smaller units. So here students sometimes get confused in their MCQs. What is the relation between 1 microampere and ampere? If they will ask microampere to ampere, we need to write 1 microampere is 10 raised to minus 6 ampere, because micro is smaller unit and ampere is the bigger unit. If we start from ampere, we need to write 10 raised to 6 ampere is 1 microampere. Other smaller unit is milliampere. If they'll ask for other units, we need to write microampere and milliampere. 1 milliampere is 10 raised to minus 3 ampere, or 10 raised to 3 ampere is 1 milliampere. So these are the relation. And the next important question, current is measured by the instrument called ammeter. So ammeter is the instrument which is used to measure current, and always it is connected in series. Later I'll explain what is series and parallel connection. Ammeter is always connected in series. This is important MCQ. Now this is also one important definition. What do you mean by 1 ampere? So here 1 ampere is constituted by flow of 1 coulomb of charge per second. When 1 coulomb of charge flows for 1 second, we call it as 1 ampere. The next important thing you can remember, like when you use the unit, if you are writing the spelling to write unit, then we use spelling of the ampere with small letter, and when we write it in symbol, capital A to be taken. So keep in mind this is also important point. Now the next topic is draw a schematic diagram of electric current. This is 2 marks question where they will mention the things what to be represented in the circuit. So here a simple circuit is drawn. This is bulb, and then ammeter. Ammeter is always connected in series as I told. Then key, if we keep the dot, it is closed. If it is not there, it is open. Then I have taken 2 batteries. In question they can ask use 3. So we'll put 3 for that. Always the bigger one is representing positive and the smaller one is representing negative. Current always flows from positive to negative. So this is how to draw. In this they can add use voltmeter. Voltmeter is used to measure potential difference, which is always connected in parallel. So that we need to connect in parallel, ammeter in series. Now the next one, what is electric potential? Electric potential is represented by V, is defined as amount of work done to move unit charge from one point to other. So here, suppose this is an electric wire, amount of work done to bring charge from this point to this point. This complete work done is called potential difference. Potential difference is represented by V. V is equal to W by Q, where W is representing work done, so its unit is joule. Q is charge, so its unit is coulomb. Thus, SI unit of potential difference is joule per coulomb, or we can write volt. If we are using the symbol, V is represented. So these all units you need to remember. They can ask for MCQs, or they can give what are the other units of potential difference. So you must be clear with each and every unit. Now the next important definition is, what is 1 volt? Now 1 volt is potential difference between 2 points in a current carrying conductor when 1 joule of work is done to move a charge of 1 coulomb from one point to other. So it is amount of work done to move charge from, that is 1 joule of work is done to move 1 coulomb charge. So here when we are using 1 joule and 1 coulomb, we call it as 1 volt. This is also important definition. Now what is the simple way, like 1 volt is 1 joule upon 1 coulomb. Potential difference is measured by instrument called voltmeter. It is always connected in parallel. So they can ask an MCQ. Ammeter is always connected in series. Voltmeter is always connected in parallel. In diagram I showed you like what is series. When we connect it with wire, we call it as in series. If it is in parallel to the wire, we call it as in parallel connection. So here series connection is with the connection and parallel is parallel to the wire. Now the next topic is Ohm's law. So what is Ohm's law? The potential difference V across the ends of the given metallic wire is an electric current. In an electric current is directly proportional to the current flowing through the conductor, provided its temperature remain the same. So what does Ohm's law says? Potential difference across the conductor is directly proportional to current. So V is proportional to I. So whenever we use this proportional sign, we need to use constant to remove it. So here the constant is R. So V is proportional to IR. If we want to get the value of R, it's V upon I. So what is this R? This is nothing but resistance. So resistance is a property which opposes the flow of electric current. So here resistance is constant. So thus we can find the unit of resistance as volt for V, and for current it is ampere. So thus the unit of resistance is volt per ampere, or we can use ohm as it was given by the scientist Ohm, or the symbol is Ohm. So these are the important, like when we will write Ohm's law, you need to write the law, then this derivation up to resistance. These units are not needed, you need not to represent them. Till here it is sufficient. They can ask represent Ohm's graph, okay, Ohm's law graph. So Ohm's law graph is represented, it is drawn by using V versus I graph. That is, V is representing voltage, I is representing electric current. If we plot voltage and electric current in a graph paper, we find that the graph is a straight line which is passing through the horizon. So this graph represents that voltage and current both are directly proportional. So if we increase potential difference, current will also increase. So both are proportional. If we increase current, potential difference will increase. If we are increasing potential difference, current will increase. Now the next topic is resistance. So here Ohm's law you can prepare from your textbook also, where you need to prepare activity and graph. Now the next one is resistance, property of a conductor which opposes the flow of electric current. So here what is resistance? It's like a speed breaker in the road. In road, why the speed breakers are given? So that we can control our speed. Without speed breaker, we'll drive carelessly. In the same way, if no breaker will be there in the flow of current, current will flow recklessly. So thus to avoid it, some opposing property is inbuilt in the conductor. So this property of the conductor which opposes the flow of electric current is called resistance. And resistance is represented by R. Its symbol is ohm. Its SI unit is ohm. Either we can represent by symbol or we can write the spelling. So this is also simple topic. Now the next topic is resistivity. Now what is resistivity? Resistivity is inbuilt property which is already present. So it is intrinsic property, or we can say inbuilt property. Means the conductor will have from the beginning onwards. So this is the inbuilt property which the conductor is having. Okay. So thus resistivity we can derive in the following way. Resistance is directly proportional to length of the conductor. So if more longer the wire, it will have more resistance. And then resistance is inversely proportional to cross-section area. So if we combine these two equations, we get as R is proportional to L by A. To remove proportional sign, we use resistivity. This symbol is called resistivity, rho L upon A. So this is called rho. Okay. Now, to find resistivity, we can have cross multiplication. So resistivity is Ra upon L. What are the units of resistivity? We know that resistance unit is ohm. For area it is meter square, and for length it is meter. So meter will get cancelled. Thus the unit of resistivity is ohm meter. So this unit you need to remember. Now the next one, as a unit of resistivity is ohm meter. Now these are important properties, important questions like factor affecting resistance. So they can ask what are the factors affecting resistance. Resistance depends on length of the conductor, cross-section area of the conductor. That is, if more fatter, wire resistance will be less. So more current is flown. If it is thinner, less current will flow, as it is inversely proportional. It depends on temperature and nature of the material. Nature means the wire is made up of what? Like either it is made up of steel, aluminium, copper. So depending on resistivity, its resistance will change. Now factors affecting resistivity. Students get confused with this. So when they will ask for resistivity, we need to write only nature of material and temperature. Don't write length and area. So as it is inbuilt property, already the conductor will have this property. So only we need to write nature of material and temperature. Now the next topic is resistance in series. Let three resistors are there, R1, R2 and R3, which are connected in series, and current I is flowing through them. So yeah, when current flows through the series connections, same amount of current will flow. So this you need to keep in mind, same current will flow, whereas the resistors across them is different. So here the potential difference will be different, that is V1, V2 and V3. For series connection, the thing which is divided, we need to start from there. So here the potential difference is getting divided. So we'll start from potential difference across the series is combination of all the three individual potential differences. That is V1 plus V2 plus V3. V1 we can replace as per Ohm's law. V is IR. So we are replacing it by IR1, IR2 and IR3. That is V parallel. Now V parallel can be written as V in series. So this we are discussing with series. So it will be Vs. That is resistance in series. I can be taken common. Thus it is R1, R2 plus R3. Thus I will get cancelled. Resistance in series is combination of all the individual resistances. So here we need to write some theory part. So this is the derivation how we are going to write. For theory part you need to write let conductor is having three resistors which are connected in series. Which are connected in series. They are R1, R2 and R3, and I is current flowing through them having potential difference V1, V2 and V3. So this you need to start out. The starting part you will write in this way, and then you will have the derivation, diagram and derivation. Then after that you need to write the conclusion part. So conclusion, resistance in series is equal to sum total of all individual resistors. Okay, it is sum total of all individual resistances. Therefore, resistance in series is always greater than the greatest value. So here, what do you mean by greater than greatest? Suppose we are having R1 as 2, R2 as 3 and R3 as 4. So resistance in series, as I told, it's R1 plus R2 plus R3. So this will be 2 plus 3 plus 4, which is equal to 9 ohm. So here 9 is greater than greatest value. So greatest value is 4. 9 will be greater than the greatest among all. So this is the conclusion which you need to write. Now this is series connection which can be asked for 3 marks or 4 marks question as per CBSE. Now resistance in parallel. So current is getting divided into parallel combination. As here the connection is getting divided into 3 parts. So here current will split as I1, I2 and I3, whereas the potential difference will remain same. So here as the current is splitting, so current in parallel will start from I1 plus I2 plus I3. For series connection, we started with voltage division. Here we will start with current division. Now I is equal to V upon R as per Ohm's law. So we'll replace I1 as V upon R1. So here the resistors are R1, R2, R3. The same way you need to write the statement here. So let the current I1, I2 and current I is flowing through the parallel combination. So it will split as I1, I2, I3. They're having the resistors R1, R2 and R3. So that statement, and then we'll start out with the derivation. So here V upon R2 and V upon R3, whereas current in parallel will be V by R parallel. Here V can be taken common. So we left with 1 upon R1, 1 upon R2, 1 upon R3. And here V upon R parallel. V will get cancelled. Therefore, resistance in parallel is equal to combination of reciprocal of all individual resistances. We need to write reciprocal. So final conclusion, resistance in parallel is equal to sum of reciprocal of all individual resistances. All individual resistances. Therefore, resistance in parallel is lesser than the least. So this is important while calculating the answer. So as we are adding reciprocals, so value will be always less than the less value. So as I gave the example 2, 3 and 4. So here for resistance in parallel, it will be less than 2. When we find parallel, it will be lesser than the least. And when we find series, it will be greater than the greatest. So these two are the topics. From your textbook, you need to read about the table, like which one will have more resistance and which will have the least resistance. From your textbook, this table is important where they have given the resistivity of different materials. Like from this, they can ask which one is best conductor. So silver is the best conductor whose resistivity is less, and among all here the resistivity which will have the greater will be insulator. Generally they don't ask, you need not to remember this all formulas, all values. So this will be given in the question. If they will ask sums based on resistivity, only you need to, if they will ask the comparison, if the resistivity is less, that is good conductor. If resistivity is more, that is insulator. Only for that remembrance only you need to follow this table. Rest you need not to prepare this table. This is also one of the important table which you need to learn from your textbook. They can ask for MCQs. What are the symbols? Like symbol representing electric cell. Then if it is electric battery, we need to represent more cells. When key is open, without dot. When key is closed, it's with dot. Wire joined, perpendicular connection. Wire crossing without joining. If one overlapping wires are there, one above other, then we use this symbol. The next one, bulb. So it's easy to draw in this way. Resistance, rheostat. So rheostat is the variable resistance. When we want to change the resistance of the circuit, we are going to use this. Ammeter is represented by A, voltmeter by V. So this is one of the table which you need to revise. Now this paragraph is very important, which you need to learn very nicely. Every year they ask question from here. So here, why the heating devices are made up of alloys. So here these lines are very important. Alloy is generally, resistivity of an alloy is generally higher than that of its constituent metals. Alloy do not oxidize readily at high temperature. For this reason, they are commonly used in electric heating devices like electric iron, toaster, etc. So these lines are very important. Concentrate and learn it properly. Next, they can ask, give reason why tungsten is used exclusively in filament. So because of this reason, as tungsten is alloy, it can withstand high temperature and can glow. That's why it is used in filament. Tungsten is used in almost exclusively for filament of electric bulb because it can withstand. So this is all reason. They can ask why alloys are used in heating devices, or they can make like tungsten is used in electric bulbs. And next, one more question they can ask, like why the heating devices does not glow but the bulb glows. As the heating device is made up of alloy, it can withstand high temperature. So it gets heated, okay? Where the bulb is made up of tungsten, whose melting point is high, thus it glows. So that is one of the important question which you need to learn. Now the last topic of the chapter is Joule's law. How you can remember Joule's law? So here, Joule's law, heat produced in the conductor, that is generally we say heat produced after PT. You has gone for PT period and lot of heat is generated in your body. So heat produced after PT. Now what is power? Power is very important. So I forgot to tell you about power concept. Power is product of potential difference and current. So you can remember power as power is very important. VI. V according to Ohm's law is IR. So thus the formula of power is I square R. When we use in series, we are applying I square R. If it is in connection, parallel connection, we need to replace this V as I upon I as V upon R. For parallel connection, we are going to use V square by R. For series, I square R. So this is important concept which you need to remember for numericals. For parallel connection, V square by R. For series, I square R. Now let's start out with Joule's law. H is equal to PT. P is very important. And T, I we can replace as, V we can replace as IR. This heat generated in a conductor is I square RT. That is directly proportional to square of the current and resistance and time. This law also can be asked for 3 marks, where you need to write 3 points that you refer your textbook, how to write the law, derivation, and law is important. Now all theory part of this chapter got over. Only we left out with numericals. So in my next video, I'm going to upload only numerical part of this chapter. Till then, once you go through with the theory part, thoroughly read the chapter. So only simple concepts are there. Go through with that. Few numericals are there, around 15 numericals. So by today afternoon, I'm going to upload it. In that way, you can complete your chapter. For more videos, please like and subscribe my channel.